Okay, so where we left off when I paused the video last time was to go over the results that you're going to see and how the very heaviest particles, such as the sand and maybe some small rocks, are going to settle fastest and be at the bottom. How the next layer is going to consist of the finer particles, the silt and the clay, and how maybe you're going to have a tiny little layer of very fine particles on top. And you might see a layer of organic material such as bugs or bits of plants. Then they are going to sink last. And hopefully the water will be completely clear when all of the materials have settled to the bottom. Then what you're going to do is you're going to get your ruler. And it's easier if you use the metric system. So you're going to measure the depth of the sand particles, you're going to measure the depth of the silt and clay, and you're going to measure the depth or the thickness of each of these layers. And that will give you the relative amounts of sand, the relative amounts of very fine particles, and the relative amounts of very, very fine particles and maybe organic material in your sediment sample. So let's think about that. All right, why do we worry about this? So the first question I'd like you to think about is what kinds of fish or insects and invertebrates might live where the bottom of the habitat is sandy? What type of animals might live where the bottom is a mucky kind of silt or clay? So by measuring the amount of sand that you have recovered in this jar, you can tell if this habitat is a sandy habitat or if this habitat is a mucky sort of habitat. Now, what kind of sediments are at the bottom of the lake, sandy or mucky or rocky? That will determine the types of animals, the types of plants that can live in that particular habitat. So this is a very, very powerful tool for describing the habitats at the bottom of lakes, at the bottom of rivers, and at the bottom of streams. Now, supposing you are an animal that lives in a sandy river bottom, and what might happen to you if soil eroding from the land is now covering the river bottom with silt or clay? It's no longer a sandy bottom. It's now a habitat that is no longer suited for your needs. Now, the reason I ask you to use a clock or a timer is how long between the time you stopped shaking or stirring and the water then became clear. What would happen to plants or animals living in that environment if the water remained cloudy for a long period of time? So if you take a soil sample from the ground and you shook it and it stayed cloudy for a long period of time, what would happen if that soil eroded into a stream and made the stream cloudy for a long period of time? So what would happen if a fish that normally lived in clear water now found itself living in cloudy water? Would that habitat still be suitable for that kind of fish? Now, this is a very simple project that you can do. You can measure the amounts of sand and silt in various kinds of habitats around the town of Vernon, and might be a very nice science fair project for you. And it is, as I say, this is a type of measurement that scientists typically make when they're trying to understand water pollution and the potential damage to habitats. It's one that I have personally made for a number of years and can be very important for talking about the suitability of habitat for different kinds of fish and aquatic animals and aquatic plants. just before we move on to the end, supposing you are a fish or an aquatic animal that his or her normal habitat is cloudy water. Supposing you love living in cloudy water, this was your normal habitat. Well, what might happen to you if the water suddenly became clear? Would that habitat still be good for you? If your normal habitat was cloudy water and now you're being forced to live in clear water? So you can learn a lot about habitats just from this very simple experiment. But now let's imagine that we're off at a construction site somewhere and you see a fence like this. This is called the sediment fence. Why might we put a sediment fence up at a construction site where the soil might be disturbed? What would happen if the soil was disturbed and it began to be eroded off the site and end up in a stream or a river? And why do we put this fence up to stop that from happening? And I'm going to let you answer that question. I'm not going to give you the answer. All right, now I said that there were also some optional things you can do with this experiment. Well, one thing you can certainly do is that you can pour off the water that remains on the top, and you can pour it into a shallow bowl. Schnitzel. Go bark. Go bark. You could pour it off into a shallow bowl, and you could look at it with a magnifying glass to see what kinds of worms or insects or other life is living in the sediments. Another thing you can try is you can spread the sediments out to dry on a piece of aluminum foil and then pass a magnet over and through the sediments and find out if there are any iron particles that are sticking to the magnet. Much of the area where we live is very, very rich in iron, and it may be interesting to see if the lake or the stream or the habitat that you're studying is also rich in iron. It's a very common type of rock in this part of the world. So there's your experiment. I'm going to be online a little bit later to answer any questions that you may have. I hope you've enjoyed this introduction to pollution and the introduction to man's impact on the natural world, and you've learned something interesting. So I hope to see you soon. Stay safe, stay well.